Hello everyone, welcome back to another exciting chemistry lesson by Adrenaline the Bazooka Prophet. Now in this video, I'm going to be talking about the calculation of the nuclear binding energy. Now this aspect is actually a very cumbersome aspect, but when you follow the way I will break it down for you, at the end of this video, you should be able to solve any questions that relates to nuclear binding energy. First question, what is a nuclear binding energy? A nuclear binding energy is the energy that is required to break up the nucleus into their corresponding, into protons and neutrons. Remember that the nucleus of an atom comprises of the protons and also the neutrons, right? Now, when we continue to a particular question on the board, which says the atomic mass of iodine 127 is this was the actual mass you were given in the question, which is 126.9004 AMU, which means atomic mass unit. Calculate the nuclear binding energy of this nucleus in MeV, which means mega electron volts, also in joule and kilojoule, and the corresponding nuclear binding energy per nucleon. And these are the parameters given to you on the board, which I'll be teaching you the steps on how to actually go about it without wasting any time at all. Now, follow the steps I would like to do it. Now, the formula for nuclear binding energy is equal to mass defect C squared, which is this C here means the speed of light. Now, the first thing we have to ask ourselves is to calculate for mass defect. How do I calculate for mass defect? Now, take note, mass defect simply means the calculated mass minus the actual mass. Now we were already given our actual mass to be this 126.9004 AMU. Now to calculate for what now? Our calculated mass. Very simple. Now you have your iodine here. Iodine here was 127. You have the atomic number to be 53. Now what do I do first of all? I ask myself some certain question. What is the proton number here? Was it not 53? Good. Now, if the proton I have here was 53, please take note, you have to convert it to AMU by using the mass of proton, which is multiplied by the mass of proton was given to us here to be 1.00728, which you will do it. Now, you come here again, the mass of neutron here. How do I get for the mass of neutron? It will be mass number minus atomic number, which is 127 minus 53. It gave me 74. 74 multiplied by the mass of neutron in AMU, which was this. Please take note, you must, after you get to atomic number, which is your number of proton, you must multiply by the mass of the proton in AMU. If it is not given to you, you have to know it. But many a time in exams, you are often given all these parameters. Now, let's go. So here becomes 1.00867. So that what do you do now? This is summation. What do? You multiply this with this. You will now add it to what now? The numbers of what now? Neutron, which is this 53 times this, 74 times this. When you multiply, you have to add that of the proton and neutron, which will give me my calculated mass. So let's go. So it will be 53 multiplied by 1.00728, right? Plus, we have 74 multiplied by 1.00 867, which gave me 128.02742. Is that clear now? Now, please follow me. Now that I have gotten for this value now, please permit me, I will have to rub this. Okay, let me rub this top here so it can be visible for you to see. Now, follow me. Now, I have gotten for my calculated mass, so that my mass defect now is now equal to what next? It's now equal to, my calculated mass was 128.02742 minus my actual mass was given to me in the question to be 126 point what now 9004. But when you subtract, that is 126 minus 9004, I add it to be 1.12702 AMU. Now, this is what I have gotten here. My mass defect now, which is the most important of them all, first is my mass defect. Now, if I'm to get my answer, take note, if I'm to get my answer of my nuclear binding energy in mega electron volt, which is the easiest, what do? I will just come here to say energy is equal to this answer here, which is mass defect, which is 1.12702 multiplied by what now? 931.5. Simple. So just come here, if you multiply it times 931.5, I will have it to be 1049.82 mega electron volt. That is when you are asked to calculate for the answer in what now? In mega electron volt. The nuclear binding energy in mega electron volt. But if you're asked to calculate for the answer in joules, which was part of the question, in joules and kilojoules, what do? Simple. Please understand my steps. That is how you used to solve other related questions with ease. Whether you're writing WAEC, NECO, JAM, Cambridge A-level exam, my friends, my viewers from India, from USA, from Britain, from Saudi Arabia, from any part of the world. Chemistry is chemistry everywhere. So it's actually very easy. I caught you, right? So let's continue. Very easy, right? Now, while we erase the board to create more room for what we are doing here, please listen. Now, let us get our answer in joule. In getting our answer in joule, we have to use this formula so that energy is equal to, we know that this is mass defect, which is now, mass defect was 1.12702 multiplied by, now, my speed of light is always constant. Is what now? 3 times 10 raised to power 8, right? You square it. You do it like that. If you do it like that, let's not make any mistake at all. 3 exponential 8 all square. We have our answer here to be, that's okay, that 1.01432 multiplied by 10 raised to power 17, what now? 17, okay, AMU meter square per second, what now? Square. So this is my answer, my nuclear binding energy. Now, simple. To now convert my answer now, please take note. To now get my answer in joules, please take note. In joules, it will be energy here is equal to what now? is equal to, you divide this one by the what now? You divide this one that you have here by a constant, which I'm to give to you now, which is 1.01432 multiplied by 10 raised to the power 17 divided by 6.022 times 10 raised to the power what now? 26. Use this constant. Well, I already do all the shortcut. This is a shortcut. The raised to the power 26, which is now equal to, that's divided by 6.022 exponential 26, which will give me 1.684 times 10 raised to the power minus 10 joules. This is in joules. Is that clear now? So I raise the board further. This answer I'm having here is in joules. Now, if I'm to get my answer in kilojoule, of course, you have to divide by 1000. To divide by 1000, which is what you're having here as, let's say, 1.684 exponential minus 10 divided by 1000. It will now give me 1.684 times 10 raised to the power minus 13 kilojoule. Can you see it now? So I've gotten my answer now in mega electron volts. I've gotten my answer still in joules. I've also gotten my answer in what now? In kilojoule. The last part is we were told to get to do it in nuclear binding energy per nucleon. And what forms the nucleon? The mass number is also called the nucleon number. So what do you do here? Very simple. To get the mega electron volt per nucleon here, simple. Just come here to say you're having this value here, which is 1049.82 divided by, of course, the mass number of iodine that we're giving is 126. So the final answer here is 8.332, right? Mega electron volt per nucleon. The same idea here, to get this one in joule per nucleon too, you also come here to also say 1.684 exponential minus 10 divided by, the nucleon is 126, which when you do it, final answer will be 1.3. Okay, let me use the red pen here. 1.3365 times 10 to the minus 12 joule per nucleon. The same idea will also operate here, meaning to get your answer in per nucleon, nucleon number means the mass number, and the mass number of iodine that we're given from the question, mass number was 126. So just these are binding energies, right? To get it per nucleon is to divide by the mass number, which what I did here. Divide this one by 126 and I got this one. Divide this one by 126 and I got this one. You can also do same of this one to also get your own final answer. And this marks the end of this video, making it so easy for us to actually tackle. If you do understand, do well to subscribe, share and like. And if you do not understand, do well to rewatch the video. Of course, ask questions. We also offer online classes, which is currently ongoing. Do well to call my number as we continue. God bless you. For now, remain blessed.